Good morning to all. Today we have our next topic, new topic, that is transition probability. By using transition probability, how to measure how to predict the future values. It is useful to predict the future values. And when will the system will be moving constant? It will not appear further increase or decrease. To decide those typical factors, this transition probability is very useful in a system. A system means it may be a school or a factory, it may be or a hospital, like that. In every system, there are collection of events. In every system, there are events. If an event occurs at a specified time in the system is Sn, and after a unit of time another event occurs, that is Sn plus 1. After Sn completes, Sn plus 1 happens after a unit of time, that is another event Sn plus 1. That is known as system moved from the state Sn to Sn plus 1. That is, the system moved to the state Sn to Sn plus 1. This movement related to probability distribution. There is a probability associated with each move. Sn to Sn plus 1 or Sn plus 1 to Sn plus 2, etc. This movement related to probability distribution. There is a probability associated with each move. That is, each transition Sn to Sn plus 1, there is a probability. This is known as one stage transition probability. One stage transition probability. One stage transition probability. One stage transition probability. If it occurs one more stage, that is two stage transition probability. If we move one and the next stage is Sn plus 2. If it happens, that is known as two stage transition probability. Now, transition matrix. What does mean transition matrix? It is a probability matrix denoted by P. It is a probability matrix denoted by P, but in our text we are using T. T for transition. For that we are using T, but generally the probability matrix is denoted by P. It has number of events. Different number of events. Those probabilities are mentioned by P1, P2, P3, etc. And then the second row, this one is taken as P11, P12, P13, etc. P21, P22, P23, etc. Because we are mentioning in the matrix, therefore using the arrays A11, A12 like that, etc. We can have a number of rows and number of columns. But all the entries are probabilities, because we are moving to one stage to another stage. There is a probability that are all denoted here. So each element represents a probability value. The sum of all the probability will be equal to 1. That is very important. Sum of the probability values. Suppose if I take a P equal to P11, P12 and P21, P22, P11 plus P12 will be equal to 1 and P21 plus P22 equal to 1. That is very important. Sum of the probability values is equal to 1 in that case, whose entries P1, P2, P11, P12, P21, P22 are all probabilities of event. So this type of matrix is called the transition probability matrix. This transition probability matrix is very useful. This is framed by the change. This is framed by the change of one stage to another stage. By using this transition, we can predict the future values and how to move to the next stage. Next one is equilibrium. What does mean equilibrium? Equilibrium means a level position. That is level position. A level position. That is, there is no more change in the distribution will happen. No more change will happen in the distribution. That is, no more change will happen in the distribution is known as equilibrium. That is level position. Let the probability distribution be X and the transition probability be P. After multiplying, after the transition takes place with this probability distribution, which yields the same probability distribution, that is the level position. That means no more changes in X after the transition is known as equilibrium. No more changes in the distribution after taking one more transition. No more changes in the equilibrium in the distribution is known as equilibrium. Okay, this is distribution, this is the transition probability, and then the distribution takes place one transition. It implies the same distribution value. That means no more change will happen in the distribution. Those level is known as level position. That is known as the equilibrium. There are several other names for equilibrium distribution. The first one is invariant. It's also known as invariant. And then the another case is stationary. Stationary. It is also called as invariant or stationary. The invariant means it doesn't change. It doesn't change. That's all. Invariant means it doesn't change. It doesn't change. That is, it will be stable. Then stationary also, the chain stops here. The chain, that means the transition chain stops here. That is also represents no more change hereafter. That is the level position. Those typical position is known as equilibrium position. Okay, suppose the given distribution is AB. The transition probability matrix is taken as T. This is also a matrix. This is also a probability matrix. If one more transition appears, when we multiply these two, the same probability distribution appears here. This transition is known as equilibrium. This transition is known as at equilibrium. So equilibrium is nothing but level position. That is, no more change will happen further. And X is a distribution function. P is the transition probability. Then applying the transition to this probability, it will yield the same probability function. That means the position is in level position. They are in equilibrium. It is also renamed as invariant. That means it doesn't change after. Then stationary, that means the chain stops here, that is known as stationary. And here one example, AB is the distribution function, T is called as transition. Instead P I am taking here T. T is the transition probability matrix. After applying AB into T, we will get AB. This is known as equilibrium. AB into transition, applying transition probability in a distribution. If it yields the same distribution again, it is known as equilibrium position. Question number 1 in exercise 1.3. The subscription department of a magazine sends out a letter to a large mailing list inviting subscriptions for the magazine. Some of the people receiving this letter already subscribe to the magazine, while others do not. From this mailing list, 45% of those who already subscribe will subscribe again, while 30% of those who do not subscribe will subscribe. On the last letter, it was found that 40% of those receiving it ordered a subscription. Then what percent of those receiving the current letter can be expected to order a subscription? What percentage of current letter can be expected to order a subscription? This is useful to predict the future. I told you already, these typical problems will be useful to analyze the future. Okay. What is given here? A group of mailing sent to invite subscriptions by a mail. In this, 45% those who already subscribe will subscribe again. This is one. And 30% of those who do not subscribe do not now subscribe. Okay, in that case 30% do not subscribe. And the last letter, it was found that 40% of those receiving it ordered a subscription. It's okay. Here is a transition happened. That is, what is the transition happen here? What is the transition happen here? 45% those who already subscribe will subscribe. Now, T be the transition probability matrix. Let A be the percentage of subscribers and B be the percentage of non-subscribers. Given 45% already subscribe will subscribe. That means 45% people are subscribing. Therefore, A is percentage of subscribers. Therefore, A is 45%. And then in B, 30 of those who do not subscribe now. That means B be the percentage of non-subscribers. Therefore, in B we have 30%. It's okay. I told you these are representing probability. This means the sum of the probability equal to 1. So here 45%, the remaining is 55%, and then here 30%, the remaining is 70%. 45% means 45 by 100, that is equal to 0.45. That means this one is 0.45, this one is 0.55, this one is 0.30, another one is 0.70. Therefore, the transition probability T will be equal to 0.45, 0.55, 0.30, 0.70. You should give more care while calculating the transition probability, because in the further steps we are multiplying only the transition probability we will find the answer. If you commit mistakes in the transition probability, your answer will be wrong. So take more care while calculating the transition probability here. Now we are moving further steps here. And finally they have given, it was found that 40% of the people ordered in the last mail. That is, our distribution is AB. In it 40% are subscribed again, therefore A is 40%. The B is unknown, the total sum is 1, therefore the remaining is 60% is unsubscribing. If it continues, what will happen? In the how many people will subscribe again is our question. Okay, now this probability function, this distribution function is 0.40 and 0.4 and 0.6. It is multiplied with the transition probability matrix. Multiplying this with the transition probability matrix, will get final answer that will conclude the number of subscribers after the second letter. So multiplying these two values will have, which is equal to, this is row, this is one column, this is one column. Row by column multiplication, multiply row by column. Here is order 1 row 2 column, 1 cross 2. Here is the order 2 cross 2. The multiplication is possible only if the number of columns in the first matrix will be equal to number of rows in the second matrix. Here is 2, here is 2, both are equal, we can multiply. The final answer will be 1 cross 2. That means 1 row and 2 columns. Okay. And then in that case 1 row 2 columns will appear. So multiply now. 0.4 into 0.45, 0.4 into 0.45 plus 0.6 into 0.3. Then row with the second column, 0.4 into 0.45 plus 0.55. We are moving to the second column, 0.4 into 0.55, then 0.6 into 0.70. So 0.6 into 0.70. You are already familiar with multiplication of matrices. So it is takes place like this way: 1 cross 2 into 2 cross 2, multiplying by row by column method. 0.4 into 0.45 plus 0.6 into 0.30. Then next column with the first row with the next column, 0.40 into 0.55 plus 0.6 into 0.70. Multiply these values, will have, which is equal to 0.4 into 0.45. That will be equal to 0.18. Multiplying these two will get 0.18, and then plus here also 0.18 or 0.18, 0.18 plus 0.18, and then here 0.4 into 0.55, which is equal to 0.22, 0.22 plus 0.6 into 0.7, 0.42, 0.42. Now adding these two values, we'll have 0.18, 0.18, 0.36, 0.36, and here 0.42 plus 0.22, which will be equal to 0.64. Now converting to fraction, this will be equal to A and B. This is a transition. After applying this transition, A equal to 0.36 and B will be equal to 0.64. A equal to 0.36 and B equal to 0.64. This implies, after the transition happens, A equal to 0.36 and B equal to 0.64. So A equal to 36%. That is our question. We have to find next move how many will subscribe. That is the question. So number of subscriptions, number of subscribers, we are assuming it as A. Therefore A equal to 36%. For if we continue the same way, if it continues the same way, if the same transition happens, the second move, there are 36% of the subscribers will again subscribe. That is our required answer. Second question. A new transit system has just gone into operation in Chennai. Of those who use the transit system this year, 30% will switch over to using metro train next year, and 70% will continue to use the transit system. Of those who use metro train this year, 70% will continue to use metro train next year, and 30% will switch over to the transit system. Suppose the population of the Chennai city remains constant and that 60% of the commuters use the transit system and 40% of the commuters use metro train this year. That is the present situation, 60% and 40%. That is our distribution function, 60% and 40%. This year, then what percent of the commuters will using transit system, and after 1 year, what percent of the commuters will be using transit system after 1 year, and the second subdivision is what percent of the commuters will be using transit system in the long run. In the long run means equilibrium, till the equilibrium. Long run represents the equilibrium. Note it clearly. If the question itself given long run, either given at equilibrium or given long run. The long run means it represents equilibrium. So the second case is what percent of the commuters will be using the transit system in the long run. When the equilibrium reached, how much percent of the commuters will use the transit system is the second question. Now the answer is, let A be percentage of people using transit system and B be the percentage of people using metro system. There are two assumptions here. Let A be the percentage of people using transit system and B be the percentage of people using metro. Then we have transition probability matrix here. Transition probability matrix. Transition matrix or transition probability matrix. Transition probability matrix. Matrix. It is denoted by T here, which is equal to AB. By the data, what is given here? 30% will switch to metro, 70% continue to transit. So 70% using transit in the first data. So transit is given as A. Therefore here 70% means 0.70. And then the remaining is the second one. The second one, how many people using that metro system? The metro system who use metro train this year, 70% will continue to metro in the next year and 30% will switch over to the transit system. So in that case 30% will switch to metro system. The first case 70% continue in the transit system and 30% switch over to the metro system. So 0.300 given. There are two data are given. The first one, listen carefully. 30 will switch over to metro. So B is metro. So 30% switch over to metro and 70 will continue to the transit system. A is transit system. 70 will continue the same system and 30 switch over to B. And the second information, who use metro train this year, 70% will continue to metro in the next year. So in the second year, 70% continue the metro and 30% switch over to transit system. It's very clearly you should understand here. 30 will switch over to metro. The first case, 30 switch over to metro, 70 will continue the transit. The second case, 70 will continue the metro. So B is metro, 70 is continue to metro and 30% switch over to transit system. So this is the required transition probability matrix. By using this, we should find what will be what percentage of the commuters will be using the transit system after 1 year. So which is our distribution function. That to find the distribution value, already I told you 60% use transit system and 40% use metro system this year. The current position is given as 60% and one another 40%. This is taken as AB. This is the present position. Then we multiply this present position with this transition probability matrix. We'll get the changes in the first year. After a year, what will be the change? Will be get through multiplying AB and this transition probability matrix. After 1 year, multiplying this probability function with this distribution function with the transition probability 0.60, 0.40 into the transition happening, that means multiply the transition here 0.70, 0.30, 0.30, 0.70. Multiplying these two matrices will get like the previous sum. This is very easy to calculate. 0.6 into 0.7 plus 0.4 into 0.3. Then we are moving to next column. 0.6 into 0.3 plus 0.4 into 0.7. Multiply these two values. 0.42. Product of these two implies 0.12. Here 0.6 into 0.3, 0.18 plus 0.7 into 0.7, 0.28. Adding these two values, we will get 0.54 and the result is 0.46 for the second one. This is the transition happening by the given condition after a year. This means A means 54% and B is 46%. So the question is, first subdivision, what will be what percentage of the commuters will be using transit system after 1 year? Now we have assumed A is the people using transit system. So A implies, this is AB. Now A implies 0.54, that is 54%. Therefore after a year, 54% of the commuters will use the transit system. Then the second subdivision, what percent of the commuters will be using the transit system in the long run? That means when the equilibrium reached, what percent of the commuters will use the transit system? I told you equilibrium here to calculate the equilibrium at long run or the long run or equilibrium or long run. In the long run, what will happen? The probability function multiplied with the transition probability will yield the same probability function. Same answer will be the answer after getting the transition. Now this will implies AB into T equal to AB. Now AB is unknown and transition is, but the first sum they have given the first year data are given, we have utilized here. But in the long run we don't know how it will be, but A plus B equal to 1 we have, okay, which implies A plus B equal to 1, because A and B are probability measures, the total value will be equal to 1. But probability function into transition will implies the probability function is the equilibrium or long run. Now AB into the transition value, we know the particular transition here 0.7 and 0.3 and 0.3, 0.7, which will be equal to AB. By use of this, we should calculate the value of A. That will be the percentage of commuters in the long run. Now multiplying this we have 0.7a plus 0.3b and 0.3a plus 0.7b will be equal to AB. These are equal matrices, just equating the corresponding values, corresponding elements. We can have 0.7a plus 0.3b equal to A. One another data is available, 0.3a plus 0.7b equal to B. In this we have two values of B, but we need the value of A. Just to omit the second data, take the first one, 0.7a plus 0.3b equal to A. And then we have sum of AB equal to 1, which implies A plus B equal to 1, which implies B equal to 1 minus A. Substitute the value of B as 1 minus A in the above equation. We will have 0.7a plus 0.3 into B. Instead B, substitute 1 minus A equal to A. Now 0.7a plus 0.3 minus 0.3a equal to A. Simplifying these two values, 0.4a plus 0.3 equal to A. Now 0.4a on the right side, 0.3 equal to A minus 0.4a. A means 1a. Here 0.4. 1 minus 0.4 equal to 0.6. So 0.3 equal to 0.6a, which implies A equal to 0.3 divided by 0.6. That will be equal to 1 by 2. That is 50%, 0.5. So if we continue the same way in the long run, that means when the equilibrium reached, 50% of the commuters will use the transit system. This is the method to identify how many or what percent of the commuters will use the transit system in the long run. If suppose if they have asked what percent of the commuters will be in the metro system, you should find the B. The B may be the value of the percentage of people using metro system in the long run when equilibrium reached. Okay. Now again explaining, after 1 year, multiply the probability function is the transition probability function. You will get 0.54 and 0.46. The first result shows the percentage of people in the transit system. Second result shows the percentage of people in the metro system after a year. And then when the equilibrium reached, what percent of the people in the transit system is the question. So for when equilibrium reached, probability function, transition probability will yield the same probability function. A and B are probabilities, therefore adding those two value equal to 1, sum of probability equal to 1. So AB into the transition probability matrix is equal to AB. By multiplying matrix multiplication, we will have two data, 0.7a plus 0.3b and 0.3a plus 0.7b equal to AB. These are equal matrices equating the corresponding element. 0.7a plus 0.3b equal to A. And the one other information is also available. We can omit that because we have two A's here. If we take two B's, we should substitute 2 times 1 minus A. But that will take a long time. To reduce the time, you should take the first equation, 0.7a and 0.3b equal to 7. So A plus B equal to 1 we know already. That means which implies B equal to 1 minus A. In this case B equal to 1 minus A. Substituting B equal to 1 minus A in the above equation, we will get this like of transformations, and will finally get A equal to 0.3 by 0.6. Cancelling those two, we will get 1 by 2, that is equal to 0.5. So the system, the percentage of the commuters in the long run will be 0.5. That means 50% of the people using the transit system in the long run. Therefore, the answer here for the first one, 54% using transit system after a year, and for the second case, 50% using transit system in the long run. This is the final answer. Next question number 3. There are two types of soaps available in the market. Their present market shares are 15% for A and 85% for B. The two types of soaps are taken A and B given here. Their present market shares are for A it is 15%, for B it is 85%. And of those who bought A the previous year, 65% continue to buy it again, while 30% switch over to B. And of those who bought B the previous year, the product B previous year, 55% buy it again and 45% switch over to A. Find their market shares after 1 year and when is the equilibrium reached. We should find the market shares after a year, that one transition, after happening one transition, and then when the equilibrium reached. It is similar to the previous problem. Okay. Now answer is, assume let P and Q be the percentage of the people those who bought soap A and soap B respectively. The product A and B are taken as P and Q. Right. The transition probability matrix T. Transition probability matrix. T equal to PQ and here PQ. Or you can take A and B, it's not a problem to you. PQ. For the first case, this is P. 65% continues in A, therefore here 65% and 35% switch over to B. So in P 65%, 0.65 65% and switch over to B, switch over 35%. 35% people switch over to Q. And then the second data they have given 55% continues B and 45% switch over to A. That means the B is taken as Q here. In this case 55%. Therefore 55% in B and 45% switch over to A. That is 45%. Are you clear? Now there are two data are given. The first data 65% continues to A, 35% switch over to Q. That is A represents P and B represents Q here. So instead A 65% right in B, P, that is 0.65 in P, and then 35% switch over, therefore Q is 0.35. The total value should be equal to 1. You should have always in your reminder. And then the second case for B 55%, that is for Q 55%, and switch over to A is 45%, that is 45%. Either if you get confused, you should write this as AB, and you can easily write AB or AB. You can keep in this way, it will not a problem to you. This means in A 65% and then B 35%, and here for B it is 55% and then for A it is 45%. You can write any of the way. So this is a transition happened. After this transition, if the transition happened after a year, what will be the position? The present market shares are given 15%, 85%. That is taken as the distribution function A, B, that is equal to 15%, 85%. By multiplying this 15%, 85% with this transition probability one time, we will get their market shares after 1 year. And then we should find the market equilibrium, market shares after the equilibrium reached, when equilibrium reached. For that purpose, we have AB into transition probability equal to AB. After a year, what will happen? After 1 year, the first subdivision after 1 year. Already I told you, I was written here, the current position of the shares of A and B are, for A it is 15% and for B it is 85% is given. So that is taken as the distribution AB as 15% and 85%, or PQ. They are taken here PQ. The PQ matrix is 15% and 85%, that is equal to 0.15, 0.85. Now multiplying this distribution with this transition probability matrix, 0.15 into 0.85 into the corresponding transition here, 0.65, 0.35, 0.45, 0.55. While multiplying by row by column method, 0.15 into 0.65 plus 0.85 into 0.45, and then with the second column 0.15 into 0.35 plus 0.85 into 0.55. Multiplying these values, we will get 0.48 and 0.52. Multiplying and adding these two results, we can get after 1 year the transition will be 0.48 and 0.52. This represents after a year the changes in the products. The people, those who bought is the percentage of the product, those who bought A and B are 0.48 and 0.52. For A it is 48% and for B it is 52%. Therefore, after a year, after 1 year, the market position A equal to 48% and B equal to 52%. 48% of the product bought by the product A bought by the people A, and the 52% of the product B bought by the people. So these are the respective percentages after a year of the two products. The second case is, you should find the product percentages after equilibrium reached. So the equilibrium reached means we have, when the equilibrium reached, PQ into the transition probability will yield PQ. Distribution function with the transition probability multiplying, will get the same distribution function. Now the transition probability is 0.65, 0.35, 0.45, 0.55. This is 0.55. Multiplying 0.65p plus 0.45q, then the next column 0.35p plus 0.55q will be equal to PQ. Will be equal to PQ. Both the matrices are equal. We couldn't add further, so just we can equate. These are equal matrices, so we can equate the corresponding elements. 0.65p, 0.45q equal to P. From this we have an equation 0.65p plus 0.45q equal to P. We know that P and Q, sum of P and Q equal to 1, because they are probability of an even, total event will be equal to 1, all the event equal to 1. Therefore P and Q are different events. One is for A, another one is for B. The total probability will be equal to 1. From this we can conclude P equal to 1 minus Q. Substituting in the above equation, we have 0.65 into 1 minus Q equal to plus 0.45Q equal to P. Now multiply 0.65 inside, we will have 0.65 minus 0.65Q plus 0.45Q equal to P. And here also we should substitute, and P equal to 1 minus Q. Now simplifying these two values, will get 0.65 minus 0.2q equal to 1 minus q, which implies q minus 0.2q equal to 1 minus 0.65. Now segregating q on one side and the constant on the other side, we'll have minus q on the left side plus q, and we have 0.2q here, the 0.65 on the right side minus 0.65. So segregating the q terms and the constant terms on the same side, we'll have q minus 0.2q equal to 1 minus 0.65. Now simplifying, this is 1q, this is 0.2q, that means 0.8q equal to 1 minus 0.65, that is equal to 0.35. Now q equal to 0.35 divided by 0.8 or 0.80. Now cancelling these values by 5. Now q equal to 0. Dividing 0.35 by 0.80, we'll have 0.4375. Therefore q equal to 0.4375. We should find the value of q here. We found the value of q, and now we should find the value of p. The p equal to 1 minus q. We have formula p equal to 1 minus q. P equal to 1 minus q. Therefore p equal to 1 minus 0.4375. Subtracting this one, p equal to 0.5625. That is 1 minus means 1.0000, then 0.437, 0.4375, which will be equal to 5, then 2, here 6, here 5, here 0, therefore 0.5625. That is 1 minus 0.4375 equal to 0.5625. This is P, and then we are writing in percentages. Q is equal to 43.75%, and Q equal to 43.75, and P equal to 56.25%, which implies when the equilibrium reached, 56.25% of the people will buy product A, and 43.75% of the people will buy the product B. So after 1 year it will happen. Therefore after a year, the changes in the product, the percentage of buying is 48% and 52%. When the equilibrium reached, we have PQ into transition probability matrix will be equal to PQ. While proceeding in the same way by the method, we'll have two equations. By taking the first equation 0.65P and 0.45Q equal to P, and P and Q represents the probability measures, that will equal to P plus Q equal to 1 and P equal to 1 minus Q. Now simplifying, we have 0.65P instead P we can substitute 1 minus Q, 0.65 into 1 minus Q, and 0.45 into Q. P will be equal to 1 minus Q. I have written the next step. Now multiply inside 0.65 minus 0.65 Q plus 0.645 Q equal to 1 minus Q. Now altering, simplifying this, 0.65 and these two implies minus 0.2 Q equal to 1 minus Q. Now segregating Q and the constants on the different sides, Q minus 1 minus 0.2 Q equal to 1 minus 0.65. Simplifying 0.8 Q equal to 0.35. Now Q 80 will get 0.4375. So Q equal to 0.4375. When converting the percentage, 43.75%. Now P plus Q equal to 1 and P equal to 1 minus Q. We found Q. Now we are working for P. P equal to 1 minus Q, then Q means 0.4375. Substituting here, we will get 1 minus 0.4375 as 0.5625. That is the value of P. The percentage P equal to 56.25%. And it is very clear to you. This is very important. And one more problem is bending in the exercise. We'll continue tomorrow. So repeatedly do this type of problems. In examples also we have two problems like this. All these problems will be asked in 5 marks. So this is very important exercise, because all the problems in this exercise are application oriented. So these typical problems will be asked in 5 marks. Definitely you should thorough last 2 exercise for 5 marks. In the first exercise should concentrate the consistency problems by using rank of A equal to rank of AB, rank of rank of A is not equal to rank of AB. Like those problems should be concentrated more and more. This is very important. All the best. Thank you.